Welcome to this webinar. Before we begin the presentation, I want to provide you with a few housekeeping items. On your screen, you will see a taskbar with icons. Each icon is assigned to a particular element of today's webinar. After the webinar is over, please take our survey to tell us how we've done. Throughout the presentation, you can network with others or submit questions to the speakers in the box next to the slides. Download resources from the folder icon. Today's event is being recorded and archived and will be available within 24 hours. For on-demand questions or comments, send us an email by clicking Email Us. If you experience any technical issues today, please refresh your browser by hitting F5 for a PC or Command R for Macs, or email webinars@bmpmedia.com for one-on-one support. And now I'm excited to turn it over to today's moderator.
Good afternoon and welcome to this webinar. So you say it's modular, what that means and how to deploy it. This event brought to you by Mission Critical is sponsored by Eaton. I'm your moderator, Caroline Fritz, editor of Mission Critical. Thank you for joining us. Today's presenter is Ed Spears, Product Marketing Manager for Eaton's Critical Power Solutions Division Raleigh. A 35-year veteran of the power systems industry, Ed has experience in UPS systems testing, sales applications, engineering and training, as well as working in power quality engineering and marketing for telecommunications, data centers, cable television, and broadband public networks. Don't forget to submit your questions, and later in the program, Ed will address as many as possible. Today's event is being recorded and archived on missioncriticalmagazine.com. And now I'm excited to turn it over to today's presenter, Ed Spears. Welcome, Ed.
Thank you, everyone. Good day, and welcome to our little discussion on modular, scalable, uninterruptible power supply systems. Now, these systems have become rather common in the industry over the last decade or so, and what's interesting is that we see many of the same benefits and capabilities across the entire uninterruptible power supply spectrum, from smaller white space or rack-mounted UPSs all the way up to the very large multi-megawatt parallel UPS systems. We're going to split it up into two sections and talk about the compact modular UPS value proposition first. The UPS is traditionally a black box with a control panel on it and a bunch of electronics inside, and what's changed is it's still a black box with a control panel, but inside there's a bunch of smaller UPSs that allows the user the flexibility to pay as they grow and to expand on demand and keep them from having to over-provision their application by putting in a UPS system that may be too large and thereby might result in some inefficient operation. So one of the first benefits of a modular UPS system is the ability to plan without having to over-provision, without having to put in a gigantic UPS system and hope that you grow into its capabilities. You can start with just what you need today and feel comfortable that you have the ability to add a little bit of capacity or redundancy or a lot of extra capacity without having to rip out the original UPS and start over again with something larger. So the planning becomes a little bit easier and a little bit more predictability in the way your power infrastructure is deployed. You can also grow by scaling the UPS if and when you need that extra capacity. Modular UPSs tend to be shelf-mounted with slide-out subassemblies that allow what we call hot swap modularity. This means that either the field service person or in some cases the user themselves has the ability to swap out batteries or power modules to expand or repair or modify their system on an as-needed basis. And that flexibility is much more useful than a monolithic UPS system which sits there and it is what it is, so to speak. What about management? With a compact modular UPS, there's two things we want to think about in terms of managing the machine. A data center operator or whoever our particular user is going to be big on using software, in this case something like VMware, for example, that would allow, in conjunction with the UPS system, would allow that user to literally or virtually direct the power where it's needed in an emergency situation. If one data center has a power outage, the processing can be directed to another location and the battery backup time can be extended or reduced depending on the load in that particular location. So a lot more flexibility to make sure that the power protection moves along with the processing in a virtualized environment. The other management key is the advanced battery management, or the ability to manage the battery system. If I have a traditional installation where I might have many, many small UPSs, maybe mounted in the bottom of each rack, each one of those UPSs has its own separate battery system. And if I'm laying awake at 3 o'clock in the morning at home, I'm probably wondering if all of those different batteries are in good shape and are going to support me during the imminent power outage. So if I have a modular scalable UPS, I'll have all of those disparate batteries in one location, and the UPS system will be able to manage those batteries as one entity rather than spreading out among many, many, many batteries where I may or may not know what the status is at the critical moment that I may need them. So the centralization really of the battery management is actually a benefit of a modular scalable UPS. Now this next slide shows what one looks like. On the left-hand side of the slide, you see a cabinet with shelves and a control panel in the top center. And along the left-hand side, the lighter colored modules with the fans on them, about the size of a shoebox, a little bit bigger. These are the power modules that the user or the installer can slide in and slide out as necessary. And on the right-hand side of the cabinet, you see the black boxes are actually battery modules. And the user is not restricted to one battery module per power module. They can start out with a lot of power modules and a very few battery modules if they don't need much backup time. Or if their requirement is for longer battery backup time, they can put in 1 or 2 power modules and fill the rest of that right-hand side of the cabinet with battery modules and have a lot more backup time, all using the same frame of the UPS system. So this allows, in addition to capacity adjustment, it allows N+1 or even N+X redundancy. So I can have an N+1 redundant system simply by sliding in one more of those power modules than I actually have to support the critical load. So this eliminates the need to have a separate UPS with a separate battery system and switchgear to tie them all together just to get that traditional N+1 redundancy that so many of our clients desire in the UPS system. The power modules now are relatively lightweight. These are transformer-free UPSs, which saves quite a bit on weight and size, and that's part of the reason we're able to have modular UPSs like you see here, and it allows you to scale that power on an as-needed basis. Hot swappable battery modules. It says lightweight here, and they're still heavy, but at least they're manageable by a single person as opposed to those multi-thousand-pound battery cabinets that you may be used to in larger UPS systems. So the backup runtime can scale just like the power capacity, and the user has the ability to change the plan sometime down the road without having to start over with a new, larger, or smaller UPS system. These universal slots like you see in this particular module, and these are the kind of things you would look for in any modular UPS, it allows the ability for the user to decide whether they want to populate that slot with battery or whether they want to populate it with extra power modules. They can mix and match and change as they go along. This is a picture of this type of UPS system from the back, and you can see that the receptacles that I may choose for the back of this UPS system are user selectable. So at the time of the original order, I can think into the future and say, okay, I'm going to be plugging in X number of racks of servers possibly in the next 6 months or the next year. What kind of twist lock receptacle might I need? Maybe I'm looking to plug in rack power strips into these receptacles on the back of the UPS, or maybe I'm plugging in individual server chassis directly into the back of a UPS system of this size. So it is also possible to take a standalone modular UPS like this small one shown here and deploy it in an IT equipment rack. So a conversion kit would allow that UPS to be mounted in your own rack as shown in the picture on the far right. And again, I can populate and depopulate power modules and battery modules as necessary. And as you can see, I can choose things like the power cable that I need on the input of this UPS and any receptacles that I want to populate on the output. If you're choosing to hardwire the output to this UPS, let's say to a panel on the wall or even an RPP, remote power panel, that can be done as well. But the receptacles give the ability to add and change things in the lineup of equipment cabinets without necessarily having to involve an electrician every time I bring in another load to put on that UPS. Part numbers that allow the system to be built to order. In other words, that flexibility should extend all the way to the ordering process so the user can decide what they need, and if they need something different or something special or something that's custom to them, so to speak, or to their application, that flexibility on the part of the vendor is always a good thing. This particular UPS is a double conversion design. Most of UPSs in this range of around 2 to 12 kilowatts are going to be double conversion UPSs, and they will typically be single phase or split phase power protection. And by the term split phase here, we're talking about a UPS system that would take in 240 volts or 208 volts from the utility source and put out on its output 240 120 or 208 120 so that they can support both higher voltage loads like 208 or 240 and 120 volt loads as well from that single UPS, and they'll choose 240 or 208 volt receptacles as well as 120 volt or IEC type receptacles. Lots of choices in a system like this because the customer will know that their needs may change over the life of this UPS. Okay, so let's talk about some applications for a modular UPS of this size. Certainly small or medium data centers or data rooms. Co-location data centers, and you may say, well, hey, a co-location data center tends to be huge. Would a UPS of this size work in that case? Well, if you look at the picture on the lower left, you know that a lot of colos will rent out or provide cages or designated areas for a given client, and that client may want to have control over their own power. They may want to decide how much redundancy they want or whether they want a dual bus architecture or something like that, and that's a lot easier to deploy in their specific cage location, so the power protection is physically and electrically close to the devices that are being protected by the UPS system. So there's an application in the white space of a co-location environment for these type UPSs as well. And they're certainly well suited for edge data centers and even micro data centers or a data center in a box type configuration. The needs for these are wide and varied in terms of how much power they need, how much redundancy they may need, and how much battery they may need. Whether or not they have a generator available may not be a given that there's a generator available for an edge data center, so longer battery backup time built into the UPS would be a handy thing to have. Network closets, of course. Remember that as we work towards the edge with our processing, it means we're moving the need for power protection closer and closer to the point of use, just like the processing and the data is being moved closer and closer to the edge, to the point of actual use. If I want that to work during environmental problems or power outages or utility power disturbances, that means all of the communications and the processing needs to have a battery backup or a power protection scheme. So things like network closets, which can be forgotten in the big scheme of things. We keep the big data center up and running. If we forget about the network closets, yes, I've got processing available, but I can't communicate. And it's very important that they have that kind of capability as well. Okay, so applications for this type of modular UPS might be a small computer room or a data closet like we mentioned, a server farm or a 911 call center. These, if you've ever deployed in this type of environment, sometimes they have big generators, sometimes they have no generator. Oftentimes they'll have a small generator for a 911 call center, and that generator may not have the reliability of the giant behemoths that they use in multi-megawatt data centers. So they will typically request longer battery backup time in a small UPS, and that can be easily accommodated with a modular scalable design. Also, in the retail and financial markets, point-of-sale equipment for cash registers and retail stores, banking automation software systems that would be deployed at the branch level in your local banking branch, back office inventory management systems for retail, both retail stores, but also things like retail restaurants and those types of environments might be ideal for this type of UPS. And certainly government applications for their voice and data networks and closets government computer rooms, and specifically for local government, things like school system computer rooms, and even at the classroom level are serving a pod of maybe 4 to 8 classrooms with a particular UPS can be accommodated with this type of UPS as well. So with those in mind and with those benefits and capabilities in mind, let's expand our concept here to a larger modular UPS system. And what you'll find is that many of the features and benefits are almost identical, even as you scale up into a very, very large UPS system. Here's an example of one. This particular UPS is about 6 feet tall and a little under 6 feet wide, and it has the capability of adding extra 300 kilowatt power modules to the existing one that they start off with. So they can deploy that extra capacity on day one. It would add about another 24 inches to the width of the UPS, or they can deploy that extra capacity if and when needed, and if necessary, any extra battery cabinets could be added to the system. And the idea here is to provide high efficient operation. The problem with oversizing a UPS traditionally, that philosophy that says, hey, I'm going to start out with a giant UPS system and to not worry about, do I have enough power, do I have enough cooling, for example, I put it all in on day one. And it may take 10 years to grow into that capacity. The problem with over-provisioning like that is traditionally UPSs did not run very efficient at very light loads. And a client could go on for years at 20%, 15%, 25% load and end up wasting quite a bit of power on a long-term basis. Modern UPSs are much, much better at this. They provide excellent efficiency today at even very, very light loads. However, if you have a UPS system that's 8 or 10 years old and you're operating at very light load levels, take a look at your efficiency on that machine and see if it's time for an upgrade based on the amount of years of operating at possible inefficient levels. High reliability and availability, just like in the smaller versions. If I put on one more UPM module or power module in a system like this, then I actually need to support the critical load, then I already have N+1 redundancy for that application. I didn't have to buy a whole second UPS with another multi-cabinet battery system and a big chunk of switchgear to tie them together. I simply add an identical 300 kW module, in this case on the left-hand end of the box. And I can do that in the field with a minimum of disruption to data center operations. And now I've got N+1 redundancy until I outgrow that, and I may have the ability to add extra modules down the road. So I can do a little bit of planning for the future, but I don't have to deploy an oversized UPS on day one. So a smart, optimized design that allows the customer the flexibility to grow a little bit or a lot whenever they need to is the hallmark of any modular scalable UPS. The inherent redundancy we talked about is shown here. This particular UPS has a section about the size of a refrigerator on the left called an Integrated System Bypass Module, or ISBM. This is where the terminations are made, where the static switch is located, and the communications in the front panel. But on the right-hand half of the machine, there's two what we call UPMs, and each one of these are identical to each other. They're 300 kilowatts each, and they basically provide an N+1 redundant or capacity parallel system. Now, this machine is all built on one base, so it installs like one big UPS. It moves around like one big UPS as I'm doing that installation, but functionally it's a two-module parallel system. So each one of the UPMs on the right-hand side is good for 300 kilowatts of capacity. So the client may elect to go ahead and deploy both of them in their original installation. So that means as long as the critical load on this date and time is less than 300 kW, the system is already N+1 redundant. If UPM2 has a problem or needs to be shut down for maintenance, for example, UPM1 does not have to shut down at the same time. It can continue to operate and provide conditioned power and battery backup until, for example, a service person arrives to work on UPM2. So that gives me the benefit of a multi-module, discrete, parallel redundant UPS system without having to incur the upfront cost and footprint of a multi-module system that would require two separate UPSs, each with large amounts of battery backup and switchgear to connect the two together in parallel. So this capability allows that inherent redundancy in a single box UPS system. This is the kind of thing you would want to look for in any modular, scalable, large UPS system. Now, this next slide shows the addition of extra module on the left-hand end. There's lots of different ways to accommodate growth here, but most of them do require, first of all, that the client go ahead and install the premises wiring to be sized as large as this UPS could eventually possibly be. So if I buy this UPS as a 300 and end up growing it to a 600, I wouldn't want to change the premises wiring at that point. I would already want to have the proper conduit and wire in place and the proper upstream breaker protection, etc. I may never need that capacity in the premises wiring, but if I do decide to expand that UPS, then that wiring is already done, so, significantly simplifying the process. So what do we see inside a typical modular UPS that happens to be one of ours, but you'd be looking for these features in any modular scalable UPS. And by the way, most vendors in this industry now offer UPSs that are in fact scalable. So the kinds of things you look for, starting at the left-hand side here, where the bus bars are mounted for connecting the battery, the input 3 phases, the output 3 phases, and the bypass utility line for the UPS, all connected over there in that far left-hand end. Most large clients want the ability to have top and or bottom cabling depending on their application. The bus bars are positioned so the installer doesn't have to pull heavy cabling into that area and then initiate bending that cable to match the bus bars. It simply comes straight up from the floor or straight down from the ceiling and lands on the bus for a relatively easy and uncrowded installation. And just to the right of that, in the center of the cabinet there, you see the input breaker, and in the bottom of that segment, there's a couple of fans you see on the front of a module, and that's the static switch with redundant fans on the front, so the loss of a fan doesn't mean an emergency situation for that UPS. That's what we call the system bypass module section, and it's intended by design not to have anything in there that's failure prone. So there are no master controls in this type of system. The controls reside in each of those individual identical UPM modules that we'll talk about on the right. Communication cards for network communications or relay contacts, that type of thing, are in the ISBM section, as is the control panel for the UPS. And then to the right of that, there are 2 UPM sections, and they are identical, each one capable of 300 kilowatts in this case. And in a system like this in the U.S., if we are going to work on either UPM with field service engineers, the fire code requires that we go ahead and bypass the UPS or put it on the maintenance wrap, the wraparound bypass that's typically deployed with these types of machines. So if I'm going to need to bypass the UPS to perform service, I want that service to be done as quickly and safely as possible. So kind of like we saw in the smaller modular UPS systems, everything is a pull-out assembly. In the top of this UPM, you see on the left there's a drawer that's a pull-out rectifier for the entire UPM. And on the right's the pull-out inverter, can slide out, slide in, and quickly get the system back up and running. Contactors, filter capacitors, fan banks, and all the circuit boards are mounted on the front of the area there, again, for fast service. It can be accomplished safely. And each of the 2 UPMs that you see on this UPS are identical. Each one has its own individual and separate controls. They do not depend on each other or on anything in the SBM section in order to function. We want them to be completely independent and independently controlled so that there's no chance for a failing module to pull down the rest of the system, which is not suffering a failure and could potentially remain online, thus providing the N+1 redundancy that we desire. So lots of things are involved both for easy serviceability and built-in redundancy. Power supplies that keep the logic boards running should be redundant. Fans should be redundant. Contactors or motor-operated circuit breakers should be present. And in many cases, the vendor will deploy some sort of service disconnect so that we can quickly and easily replace subassemblies rather than having to perform a detailed disassembly of the machine, followed by a long time-consuming reassembly. The philosophy for service is the field replaceable unit, sometimes called the FRU or FRU. The idea is to isolate the problem subassembly, slide it out, slide another one in, get back online as quickly as possible. So the service capabilities in the service process needs to be both safe and fast, so we can put that client back online in normal operation as quickly as possible. The inherent redundancy operation we talked about before. If the UPS system, which in this case has 2 of those 300 kilowatt UPMs, it might have 3 or even 4, but in this case, if we have 2, that means if I have less than 50% load at any point in time, I can suffer the loss due to failure or overload of one of those power modules. And if the remaining module is not overloaded, it will remain online and provide conditioned power and battery backup while waiting for the service operation to commence. If I had a larger system based on the same UPM model, let's say it has 3 of those UPMs, now my load level is 66%. As long as the load is less than 66%, then I can live without any one of those 3 power modules. So if I have a problem, if I need to do maintenance, I can disable or take the affected power module offline, and the UPS system can remain online. And in many parts of the world, that's exactly how we service it. We actually do energized servicing of machines in parts of the world where the electrical codes allow that. Unfortunately, here in the U.S. at 480 volts, it's not allowed to work on the machine if there's 480 volts anywhere in the black cabinet, so to speak. So we err on the side of safety there, so the serviceability needs to be very safe, but also very quick, so we can go back online as quickly as possible. Here's an example of some of the benefits of using a modular UPS system. In the top part of this slide, we see a client that has a requirement for N+1 redundancy, and they've deployed it in the conventional manner that's been done for probably 40 years. They have a critical load that's in the range of 200 kVA. So they've deployed in the blue blocks there 2 225 kVA UPSs with a tie cabinet or SBM or system bypass module to tie those 2 independent UPSs together. Each 225 kVA has its own independent controls, and they're physically separate from each other. Each one generally will have its own discrete battery system, which might consist of 2 to 4 large battery cabinets that need to be deployed on each of those 2 UPSs. There's also the consideration for installation time and cost on site. The cabling from each UPS output and input to the tie cabinet, as well as battery connections and bypass connections, a fair amount of conduit and copper has to be deployed. The total footprint and total weight you see there, in this case, footprint around a little over 35 square feet. So if I do the same thing with a modular UPS at 600 kilowatts, I have 2 300 kilowatt power modules, but they're in the same box, built on the same physical platform. So I have the same building blocks as I have up above. In this case, I have 2 300 kVA power modules, and the tie or SBM cabinet is built into the module itself. They're isolated from each other electrically, but they're actually built together on the same footprint, so I can have one battery backup system that serves that modular 600 kilowatt UPS. So the need for the external tie cabinet goes away. It's built into the machine. The need for multiple discrete battery systems goes away as well, and you can see how that reduces footprint to a little over 16 square feet, not counting the batteries, and the total weight drops by well over half of what we see up above. So the rest of this slide quantifies the approximate space savings, assuming about $166 per square foot per year of operation in a UPS installation, and even cross-country freight savings depending on where I'm going to deploy the machine. So there are some significant savings on day one when I put this thing in footprint and upfront cost. There's also savings in total cost of ownership. If I have 2 UPS systems and 2 battery systems, I'm going to need a maintenance contract for each of the UPS systems and another maintenance contract for each of the 2 battery systems. Now, they're co-located on the same site, so the price should be reasonable for that, but certainly not as inexpensive as having one maintenance contract for my modular UPS and one for my single battery system. So over the 15 to 20-year service life of the machine, I would end up having a significantly lower total cost of ownership. What if I want more power than I can get in a single lineup of one of these modular UPSs? Most of us vendors, we top out for a single UPS, even if it's a modular design, at around 1,000, 1,250, or 1,500 kilowatts. That'd be 1.5 megawatts of power. Well, we have a lot of clients who need even more power than that. Some of them are looking for 3 and 4 and 5 and even 10 megawatts of UPS power. In many cases, we can split that up into discrete systems. But how big can I get with a single UPS, and does it give me an advantage to have a modular design? Well, let's take a look at some very basic block diagrams here. This, again, is showing a 600 kilowatt UPS with the N+1 capability, and the customer is deploying this in a traditional N+1 redundant system. So on the left-hand side of the diagram, you see 2 UPMs and an IOM, which is simply an input-output module where the cabling lands for that UPS. Each UPM is 300 kW, so that's a 600 kilowatt UPS. The critical load, looking at the block in the bottom of the slide there, is 600 kW, but the client desires N+1 redundancy, so they're going to go the conventional route and get another 600 kilowatt UPS system and another set of batteries for that system as well. And then the SBM, or the bypass module, which contains a static switch, if you can see my cursor in this part of the slide here, would be common to both of the separate UPSs. So the UPSs would come to the system bypass module where their outputs would be tied together in parallel, and I have 2 600 kilowatt UPSs, 2 sets of 600 kilowatt batteries, and only 1 600 kilowatt critical load. But the idea is if a problem develops in either UPS, the other UPS is big enough to handle the capability. And in a modular system like this, you see I could suffer the loss of 1 UPM on the left-hand side UPS, and if I'm having a really bad day, I could suffer the subsequent loss of a UPM over on the right-hand side. That would still leave me between the 2 UPSs with 2 300 kilowatt UPMs available and running that could support that 600 kilowatt load. So my mission critical redundancy there would actually be N+2 in this traditional type situation using modular UPSs. However, we would recommend that be contrasted to what we see here, which does the same thing in terms of redundancy. Here we have 1 UPS, and it's got a total of 3 300 kilowatt UPMs. The ISBM segment in the middle there is the tie cabinet that ties them together. 600 kilowatt load, I've got 3 300 kilowatt UPMs. Any one of them needs to be taken off for service or shuts down due to failure. The other remaining 2 UPMs continue to support the 600 kilowatt critical load, so I have that N+1 redundancy without buying a second UPS and battery system. Very attractive value proposition for a lot of our clients. Now, suppose as we get a little more complicated here, I want to parallel UPSs and I end up with unlike KVA ratings. Traditionally, we've basically said, hey, if you want to parallel UPSs, you need to parallel them all the same size, cookie cutter. Well, nowadays, that's not definitely necessary with a modular UPS. Let's suppose the customer has a long-range plan of 3.3 megawatts or 3,300 kilowatts, which shows at the bottom of the slide. But they don't need that on day one. They don't need anywhere close to that much capacity on day one. So they install a 600 kilowatt UPS over here on the left with 2 UPMs, and that's all they need maybe for the first several years of operation. So time passes, the system functions as expected, and all of a sudden something changes, something unexpected happens. For example, the powers that be decide that maybe they want to consolidate the Chicago and the St. Louis data centers in this one facility, so they need a lot more power and they need it right now. No time to rip it all out and start over again with a bigger UPS system. So what they do is they bring in a second UPS that's bigger than the first UPS. You'll notice the one on the right has 3 UPMs. That's a 900 kilowatt UPS paralleled with a 600 kilowatt UPS. Is that going to work? Is it going to load share properly? Actually, it will, because the system simply regards this not as a 600 kW paralleled with a 900 kW, but simply 1, 2, 3, 4, 5 identical UPMs everybody load share, everybody synchronize, and the system functions properly. Now, as time passes, they may need more capacity or they may want more redundancy. Do they have to roll in another one of these large UPSs? Not necessarily. Remember that each of these UPSs can add an additional UPM mounted on the left-hand end of the lineup. So they can bring in another 300 kilowatts of capacity at any time and install it in the field, or if they find that they're not redundant and they don't want to go get another large UPS and battery system, they can simply add an extra UPM on the left-hand end of either of those modules and retain that highly desirable N+1 redundancy. So by this point in the presentation, you may have your head spinning just a little bit with all the different puzzle pieces and the ways that this kind of system can be put together. But that's why your UPS vendor and manufacturer has a team of application engineers that can help you through the process and make recommendations, tell you the pros and cons, what's going to be the most cost-effective, what's going to be the most reliable way to deploy a modular scalable UPS system for maximum benefit. Once we know what you need and what you want, then we as vendors can offer probably several different options to give you some choices and a clear understanding of the pros and cons. Now this last slide here is a block diagram of a distributed bypass system where each one of the 4 UPSs that are shown across this slide has its own independent static switch. So this is the most common way of doing parallel systems for redundancy or capacity today around the world. It does put it in a position where each UPS system does need to be the same size, but these kind of systems, especially if you have 3 or more UPSs in parallel, offer the ability to save significantly on cost of tie cabinetry and cost of the UPS systems and batteries themselves. So we recommend that you consult with your application engineer. In some cases, if you have more than 3 UPMs, a traditional system with a centralized bypass may be the most cost-effective. If I have 2 or 3 UPSs in parallel, might save some money to go with the distributed bypass. We should comment the distributed bypass is far and away the most commonly deployed parallel systems around the world from every UPS vendor out there. So lots of possibilities, lots of ability to save money and footprint on day one with a modular scalable UPS while still ensuring the most optimum possible total cost of ownership over the 15 or 20-year service life of the UPS. So we stand ready, along with the other vendors in the industry, to help you with your decisions and your planning, whether you have a small UPS that you want to deploy in a network closet or a monster megawatt UPS that you want to put in the basement of your new data center. We have lots of options today that didn't really exist a decade ago. So at this point, we want to open it up for questions, and I'll be glad to attempt to answer any and all questions that you may have.
Thanks, Ed, for a great presentation. Okay, David wants to know, is there a way you can match AB topology to, say, dual-corded racks with a singular modular UPS with redundant UPMs?
That's a good question, and it's a little difficult to do because when we do redundant UPMs, we're by definition tying them together at a single point. So there is a single point of potential problem there if I were to have a fire in a tie cabinet, just to give you a doomsday scenario there. Even a multi-module parallel system would not be able to provide a protective path in that case. That's why we see the large number of dual bus architecture systems out there. It's because they have separate tie cabinets in a mirror image configuration, and there's no way that a problem in one system, or the A system, for example, could affect the B system. So that's one of those situations that if I want to take ultimate advantage of my dual power cord servers and a literal 2N UPS system, I can still use modular redundant systems on each side, but I would not be tying them together at a single point there. And if I have a single lineup, let's say I have 4 UPMs in one long black cabinet, and I say, gee, I want to dedicate 2 of them to an A side UPS and 2 of them to a B side UPS. That's certainly a good idea, but the problem is we have no way to do that mechanically. So what we would recommend is set up a 2 UPM system on the A side and a separate 2 UPM system on the right side, so that I would have some literal and figurative space between those systems, so they're completely isolated from each other, both electrically and physically.
Are modular UPSs more expensive than monolithic versions?
Typically they are, not in every case, but a modular UPS system tends to have more parts, separate controls for each module, separate internal breakers and contactors for each module. And the general understanding is the more parts you have in a machine, the more likely a failure may occur. But keep in mind that these are usually deployed as N+1 redundant systems. So the failure of any single part will not result in a power loss to the critical load or a transfer to bypass. The system simply remains online if it is redundant until service folks get there to actually repair the UPS system. So in general, modular systems tend to be a bit more expensive and a little bit larger in terms of footprint. So is that a situation where, hey, everybody makes modular systems, you're stuck with that? You'll find that most of us vendors offer both modular systems and monolithic systems. Monolithic systems tend to have a smaller footprint, a little bit lower upfront cost, and a little bit fewer parts. You don't have the scalability or the inherent redundancy. But there are a set of applications where the client simply doesn't require that. A good example would be a multi-tenant data center or a colo operator. And you can talk to them about, hey, do you need the ability to scale your UPS as needed? And they may say, no, I don't need that capability. Before I even start building my building, it's going to be 95% occupied, or I'm not allowed to start the build. So that client knows how much power they need and how much power they're going to need over the lifetime of that building. So a scalable system may not be the best for them. So you look for a vendor that can offer flexible solutions, and while there's a great many advantages to a modular scalable UPS, the cost and footprint advantages of a monolithic UPS need to be compared so that the client can choose what's best for their needs.
Carl wants to know what your thoughts are about modular for mobile applications, for example, on job sites.
That's something where we have found, and our competitors have found too, that is a great application for a modular UPS system, because once I decide to put a UPS in a mobile application that's traveling over the road or whatever, we found that the client base tends to not be very standardized. Some of them need a little bit of power, some of them need a little more, some of them need a lot of power, some of them may find that the critical loads they're supporting may change depending on where and how they're deploying this modular power system. So it becomes very handy to be able to offer a UPS system that is configurable and scalable. So a client may say, for right now, I only need 200 kilowatts, and for this other system, everything in the module, the enclosure is going to be the same, but I do need a little more power. I don't want to have to oversize the UPS because I don't have space in a typical mobile application. So a UPS system that can expand in minimum footprint gives a lot of flexibility for the manufacturer and the operator of a mobile system, while allowing the vendor of the UPS to offer the same product line with the same feature, benefits, controls, field service parts, etc., for an application that can vary significantly depending on the application that the end user wants to use.
Steve asks, is there a point where you can no longer add modules, or are you only restricted by the space you have?
That's a very good question, and the answer is yes. Almost always the restriction has to do with the available power in the premises wiring in the building. So in other words, if I put in a megawatt's worth of building wiring, then the UPS that's connected there should not get any bigger than 1 megawatt. The other thing that we have to think about is the I/O module, or the thing we kept calling the SBM, or system bypass module. That module is a single piece of the UPS system that contains things like input breakers, bus bars, terminations for cabling, the static switch, for example, and all of those things are size sensitive. So on the one hand, my I/O module has to be sized for the maximum possible that UPS could ever be. But the expensive and space-intensive power modules can be added on an as-needed basis until I hit the point where my I/O module can't handle that much current. At that point, I have to go to a bigger UPS.
Do UPS modules share a common battery in a typical system?
In a modular UPS system, more often than not, they will share a common battery. So the question likely is that a reliability issue? And we recommend, as do our other folks in the business, to have a multi-string battery. So the problem or an integrity problem in a single battery string would not remove the backup capability of the entire UPS system. So a multi-string battery is better than one large single string of batteries. That being said, in the smaller UPS environments, let's say 60 or 75 kVA and below, there are some modular UPS systems that have a discrete battery dedicated to each slide-out power module. That way, the battery connections are not common across the multiple power modules, so a problem in a battery module would only affect its associated power module, allowing the remaining power modules to run on battery and get the full capacity of their integral battery. So that's the ultimate in redundancy there. But when you get into the larger systems, that kind of scheme becomes awfully expensive and space intensive. So generally you will see in a multi-module UPS system or a modular scalable UPS system, there will be a common battery for all the little UPMs that make up that system.
Ramsey wants to know, how do you manage battery scalability? Typically, he starts with a 200 kilowatt and in a year will scale up to 500, for example. He needs to get his batteries in, and he'll mix old and new batteries, and he says it's not ideal.
Right, that's a good point. First of all, you want to make sure you have physical space for all the batteries that you may eventually need. It is important, though, that if I'm going to start off, let's say, at 200 kW, and maybe I need 5 minutes of battery backup time, that I don't necessarily want to oversize that battery on day one. Because remember, typical valve-regulated lead-acid batteries in this application are going to have a 5 to 7 year service life. And so if I put in all the batteries on day one, then the clock starts on the service life of those batteries, and at year 6, for example, I'm going to have to replace all of those batteries. So we recommend having enough space to grow your battery, and we recognize that they're big, ugly, and heavy and all that, but start with the battery that you need. And then let's say in 2 years, I grow and I need to roll in a few more battery cabinets. Is it okay to roll in the new ones and attach them in parallel with the older battery cabinets that have been on site? That's a subjective question. And in general, for battery systems that are in the range of 2 to 3 years old, it's reasonable to go ahead and parallel new batteries with old batteries. There is a tendency for the older batteries to pull the new ones down to their level, but it is something that that can be considered. If those batteries that I originally installed are, let's say, 4 years old, then do I want to bring in new batteries and put them in parallel with the old ones? That's the line where, in general, most vendors are going to recommend, nope, let's go ahead with a whole new battery system there. It becomes a little bit risky to parallel very old batteries with brand new batteries. And by risk, I mean the possibility of shortened life for those new expensive batteries that you just bought. So it is a subjective question, and different vendors may tell you different things. But in general, if I've got a battery that's around 2 years old and I want to expand that battery system, it's okay to bring in new batteries. You want to make sure generally that they're from the same vendor and the same battery model, or at least if you can check with the vendor if they're the same impedance, I can parallel multiple strings of batteries.
Michael asks, can you parallel with three-phase, three-wire systems, or does everything need to be three-phase, four-wire?
We and most of the other vendors can parallel with three-phase, three-wire or three-phase, four-wire. It is more common to parallel, especially at 480 volts, to parallel three-wire systems. But we, in most vendors, if not all of them, recommend that the upstream source be a grounded Y connection. I don't necessarily have to pull a neutral wire over to my paralleled UPSs. I can treat it from that point as a three-wire system. But it's more common to parallel three-wire to three-wire, but most vendors can also parallel four-wire to four-wire. And if I'm talking about, for example, a smaller system that's rated at 208, 120 volts, then, of course, in order to support the critical load 120-volt devices, I would have to have a four-wire UPS system, and it may be part of a parallel system. No problem there.
Modular UPSs have a larger parts count. Doesn't that impact the reliability?
From a pure standpoint of how often does something break, in general, more parts are going to mean things fail more often. However, keep in mind that in a system like this, most clients are going to deploy it as an N+1 redundant with one extra UPM. So that means the failure of any one part, fuse, circuit board, semiconductor, fan, capacitor, will result in that individual power module disconnecting itself instantly from the others, and the fact that the UPS system is at that point not overloaded means that it will remain online with protected power and full battery backup until a service engineer arrives on site to effect the repair. So while there are more parts, there is the inherent redundancy which is typically used in a modular scalable system that, as a result, gives you better reliability over the life of the UPS.
Can your system work at 575 volt or 4 160 volt applications?
We can do 575. There are a few UPS vendors that can do medium voltage, 4160 volts, for example. I would say the bulk of the data center applications are 480 volts or 575 or 600 volts up in Canada. When we make the jump to the medium voltage, as you can imagine, there's significant differences in electrical insulation needs and safety requirements and things like that a lot of us vendors are just a little bit nervous about. But if you check on the internet, you will find there are vendors of UPS products that do provide medium voltage or greater than 600 volt capabilities with their UPS.
Can the user change out or swap the power modules?
Depends on what the National Electrical Code allows. Generally, if the UPS system is rated at 208 volts input and output, then the power modules, at least potentially, are replaceable by the user. You want to check with the vendor to make sure that they allow that. If it is a 480 volt or one of the 575 volt UPSs that we mentioned in the previous question, in this country and in Canada, it is pretty much forbidden for the user to be replacing power modules or even the field service engineer at that point because of the potential for arc flash and high currents at the higher voltage, etc. So, in general, if I have a modular UPS that's 208 volt rated or smaller, 120 perhaps, in general, the modules will be replaceable with the system online, and oftentimes they're rated to be replaced by the user. The user, I should recommend, should always have the appropriate PPE or personal protective equipment that will be recommended by the vendor and by OSHA for operating these types of systems on site.
Well, that's it for questions. So that concludes today's webinar. Please join me in thanking Ed Spears for his presentation, as well as our sponsor, Eaton. If you have any additional questions or comments, please don't hesitate to click the Email Us button on the console. As you exit today's webinar, please take a couple minutes to complete our survey. We strongly welcome your detailed comments. Please please visit webinars.missioncriticalmagazine.com for the archive of this presentation, as well as information about our upcoming events. We appreciate your time and hope you found this webinar to be a valuable experience.